Hey everyone, so we are going to learn about lesson 3-4. It says all quantities are not created equal, and in this lesson we are going to be talking specifically about how to solve linear inequalities and their application problems. So before you move into this lesson, it's really important that you fully understand how to solve regular linear inequations, so not linear, just like exactly what we did in 3-3. So make sure that you know how to solve equations, and if you have any questions on solving equations, I'm going to recommend that you go back and look at that and ask me any questions that you have before you get into this lesson, because we're going to use a lot of that in this. All right, so with that in mind, it says here we have a couple things. An inequality, so it's right here. Here's the definition of inequality. It means two things that are not equal. So for example, 2 is less than 5 is a true statement. Okay, the inequality x is greater than 3 is a statement that shows that x is more than 3. So what numbers are more than 3? 4, 5, 6, 7, 8. Okay, so those are just some things to think about. Solution to inequality is a set of numbers that makes the inequality a true statement when you substitute in for the variable. So right here it says name a number that makes x is greater than 3 true. Okay, well, what numbers are greater than 3? 4, 5, 6, 7, 8. Okay, you can go on. Could you say 3.1 here? Yes. Could you say 5.5? Yes. Could you say pi? Sure. Okay, it does not, the number does not have to be a perfectly whole number. It's any number, including decimals, fractions, irrational numbers, that make the equation or the inequality true. What number makes x is greater than 3 false? 3, 2, 1, 0, -1, -2, -3. I just want to take everyone take a second. Why did I include 3 for this problem, but I did not include it in the statement that says x is greater than 3? So why is 3 false? Okay, if you plug it back in, it would say 3 is greater than 3. Does that make any sense? No, 3 is equal to 3. Okay, so because it doesn't have the equal to symbol on the bottom of this inequality, then that means that it's going to be a false statement. All right. So right here, this is a review of how to solve an equation. So just something that you can look back on if you need help. All right, so looking here, this is getting into learning how to determine about inequality signs and what operations we can do that would not impact the inequality sign. So for example, number 1, it says add 8 to both sides. So 10 plus 8 is 18, 20 plus 8 is 28. Well, if you look at that, which direction would the inequality go? Is 18 less than 28, or is 18 greater than 28? Well, 18 is less than, so I'm keeping the exact same symbol. Now it says add -8. So 10 plus -8 is 2, 20 plus -8 is 12. Well, 2 is smaller than 12, so 2 is less than 12. Okay, inequality sign stays the same. Now, subtract 6. 10 take away 6 is 4. 20 take away 6 is 14. Well, 4 is less than 14. Okay, so the inequality sign stays the same. Now, number 4, subtract -6. Think for a second. When you subtract a negative, what are you really doing? Remember, you're subtracting a negative, so you have 2 negatives, which turns positive. So we're really doing addition here. 10 subtract -6 is 16. Okay, 10 plus 6 is 16. 20 subtract -6 is 26. Well, 16 is less than 26, which is keeping the inequality sign the same. So when you think about this, if we did addition like we did in number 1 and 2, or subtraction like we did in 3 and 4, did the inequality signs change? Okay, no. So here it says adding or subtracting the same number on both sides does not change the direction of the comparison symbol. Okay, so when we are just doing addition or subtraction, you do not need to worry. The symbol is going to stay exactly the same, and this will all make sense when we talk about multiplication division on the next slide, why this is important. So just right now, just know, if we're doing addition or subtraction, inequality sign, if it says greater than, it's going to stay greater than. If it says less than or equal to, it's going to stay less than or equal to. All right. Now, when we're solving an inequality, we're doing the exact same steps that you do to solve an equation. So how do I get rid of a minus 5? You're going to add 5 to both sides. 9 plus 5 is 14. So I get x is greater than 14. Now, to graph an inequality, we're always graphing on a number line because remember, what does x is greater than 14 mean? It means any number that's greater than 14 is true in this inequality. So what numbers are greater than 14? 15, 16, 17, 18, and so on. So I'm going to put a 14 in the number line, and I'm going to shade to the right because we said numbers greater than 14 are 15, 16, 17. Well, where are those numbers on the number line? They are to the right. Okay, now, quick note, and I put this important note right here. If the symbol is less than or greater than, you are going to put an open circle on top of the number. Okay, if the symbol is less than or equal to or greater than or equal to, we're going to put a closed circle. So as you can see in the second problem, the symbol is less than or equal to, which is why I put a closed circle. The closed circle basically shows that we're including this number, and the open circle means I'm including everything up until 14. Okay, and we can check this answer because I chose 24. It's just any random number. You could have chose 15, 16, 17, plug it in. 24 take away 5 is 19. Is 19 greater than 9? Yes. If I chose a number, right, that did make this a false statement, what do you think that would mean? Well, it would mean that you shaded the wrong side and you have to turn your arrow the other direction, okay? So that's just a quick check for you. Same thing, solve the second one. This has t plus 11, so I'm going to subtract 11 from both sides. I get 5 minus 11 is negative 6. So t is some number less than or equal to negative 6. Well, what numbers are less than negative 6? Negative 6, negative 5, negative 4, negative 3, negative 2. Those are all numbers on the left-hand side, which is why my arrow is going to the left. And I just want to note that I did say negative 6 as being a correct because negative 6 is less than or equal to negative 6 because it has that equal to symbol. And then for my check, I chose negative 10 just because negative 10 is a nice number that's less than negative 6, and negative 10 plus 11 is 1, and 1 is less than or equal to 5. So it checks out. All right. So this one says, write a verbal description of what the solution sets of two inequalities in the color box really tell us. So the first one has been done. So basically what this is saying is we're looking at these two equations that were given to us up here. And the first one, we got an answer, x is greater than 14, right? So it means any value of x greater than 14 will cause x minus 5 to be greater than 9. So for the second one, any value of x that is less than or equal to negative 6 will cause t plus 11 to be less than or equal to 5. There's two did you get it? I did them over here. I did not do the graphs, but just make sure you got the answer. This graph you would shade to the left, and this graph you would shade to the right. This one would have a closed circle, and this one would have an open circle. Okay, so moving on past addition and subtraction. Now we're going to be looking at multiplying and dividing. So if I was to multiply both sides by 2, 10 times 2 is 20, 20 times 2 is 40. Okay, which one's smaller? 20, so 20 is less than 40. Notice nothing changed. Multiplied by negative 2. 10 times negative 2 is negative 20. 20 times negative 2 is negative 40. Okay, well, what's true? Negative 20 is greater than negative 40. What do you notice happened to this inequality symbol? Does everyone see how it flipped? Okay, why do you think it flipped? What did we multiply by? We multiplied by a negative. Okay, divide by 5. 10 divided by 5. Whoops. 10 divided by 5, that should say 2, not 50. 20 divided by 5 is 4. Okay, so it's going to give us the same result. I multiplied by 5. I wasn't paying attention. So 2 is less than 4. Notice that the inequality did not change. Okay, and then this one, I multiplied again. I really wasn't paying attention here. Divide both sides by negative 5. Well, 10 divided by negative 5 is negative 2. So that should be a negative 2. And 20 divided by negative 5 is negative 4. So we have negative 2 is greater than negative 4. All right, so let's just pay close attention here. On 7 and 9, we multiplied and divided by a positive. Note the inequality sign. It stayed the same. Well, in 8 and 10, we multiplied and divided by a negative. And what happened to that inequality sign? Everyone see how the inequality sign flipped? So whenever you multiply or divide by a negative, the inequality sign has to flip, okay? And that's just because we're changing the sign of their original number, which means that it's going to change. So if you multiply or divide both sides of an inequality by a positive number, the direction of the symbol is going to stay the same. If you multiply or divide by a negative number, the direction is going to change, okay? Here's a couple examples for us to do. There's 4 examples. 2x is less than 10. I'm going to divide by 2. I divided by a positive, so it's going to stay the same. X is less than 5. Open circle, shade to the left, okay? I used 0 in my check because 0 is less than 5. This one, I'm going to divide by -3. Notice how my answer says z is less than or equal to -4. I had to change the greater than or equal to a less than or equal to because I'm dividing by a negative. Okay, so just make sure you keep that in mind, and I'm choosing a closed circle because it has a equal to symbol. And what numbers are less than or equal to -4? I chose -8. Okay, you could plug anything you want. Now, I know that there are going to be some questions on these next two because there's fractions in there, but just think, if it has 1/4 t, well, what is the opposite of 1/4? What is the reciprocal of 1/4? That's what we have to multiply by. The reciprocal of 1/4 is +4. So 4 times 1/4 is going to make this cancel. So I'm just left with t is greater than -12. I'm not flipping because I multiplied by a positive, so it does not change. And then that should say -12, not 2. All right, now -1/3. How do I get rid of a -1/3 through multiply? Well, the reciprocal of -1/3 is -3. Note that when you take a reciprocal of a number, the sign is not going to change. So I'm still multiplying by a negative. So this sign had to change to a greater than or equal to. And again, it has a closed circle because it has an equal to. All right, and then here's 2 more examples. I did, and the did you get it? I just want to note in A, the reciprocal of 2/3 is 3/2. So I multiplied both sides by 3/2. All right, and over here, there's a quick summary of solving the steps of a linear inequality for you to review, which is exactly what we went over. Okay, the did you get it? This is a very complicated problem compared to what we were doing. So make sure that you spend some time, do a bunch more of these. I posted the mixed practice additional problems on Blackboard, so make sure you look at those and try to do them and graph your solutions and make sure you can get those answers. When you distribute here, make sure -2 times x is -2x, -2 times -5 is +10. And then here, x and -5x, when they combine, they make -4x. And I just want to note that when I did this, so you got to follow my arrows because I didn't have enough room, this is not the only way you could do this problem. But I purposely added 4x to both sides first because I know that -4 is a smaller number than -2. And by adding 4, I'm going to turn that into a positive x. And the reason why that's important is because if you did the other way and you added 2, I would have had a -2, and then you would have had to divide by a negative in the end. So it's just one more thing to have to worry about with the sign. So whenever you're dealing with inequalities, do everything you can to keep that variable a positive so that you don't have to worry about dividing or multiplying by a negative in the end. All right, and that is the end of the classwork. And I'm just going to stress again, please make sure that you look at the mixed practice and do more of these examples. Try the group work on your own before you look at the next video, just so that you can see how you understand this and what questions you need to ask. And just remember, come talk to me during office hours. And if you need other times, please reach out to me and we'll schedule another time that we can talk. All right, bye.